Containers are bound to be disruptive in the data center. They're going to impact every process, person, and technology. Storage is no different. In turn, software-defined storage is going to impact the way that storage is dynamically provisioned and managed specific to containerized applications. Before we look at storage for containers, let's take a step back and talk about what containers are. A good way to think about what containers are is to take a look at where we came from, which is a virtualized environment, as you see in this picture. At the bottom, you have a bare metal server, on top of which there's a host operating system and a hypervisor that essentially works as a hardware emulator for a number of virtual machines sitting on top. What you see inside of each of these virtual images is an application, its libraries or dependencies, as well as an entire guest operating system. So with a container environment, we get rid of the hypervisor as well as the individual guest operating system. What that translates into directly is that there's fewer bits and therefore faster instantiation. So we are going from hours from a bare metal environment to minutes in a virtualized environment to seconds in a container environment. Also, containers are meant to support the scale that we expect from a microservices-driven architecture. So we talked about tens or hundreds of virtual machines. We're going to hundreds or even thousands of containers. Now, let's talk a little bit about storage for containers. The reason that we need persistent storage for containers is that containers by nature are ephemeral. What I mean by that is that if containers die or the process gets rebooted for some reason, the state of that container is lost. Let's take a look at an example. The dotted line here represents a container cluster, and I'm going to draw in a master node. And for the sake of this example, we're going to consider this a Kubernetes cluster. However, all the work that we have done at Red Hat Storage is fully supported within the recently announced OpenShift 3.1, as well as the container host platforms, Red Hat Linux 7, as well as Red Hat Atomic Enterprise Platform, which is available as a public preview. So in this case, we're going to look at Kubernetes. And as I said, this is the master node. In this example, we're going to look at 3 nodes within this cluster. And it's not only about being able to store the state of the application. You could use local storage. However, if the container dies, you lose the state. But it's also about application instances themselves moving around between the various members of that cluster, and persistent storage not being able to be offered to them natively through container technology. And therefore, at Red Hat, we have worked to build volume plugins with Kubernetes for a number of storage protocols to give you choice. So we have worked for a Gluster FS, a Ceph RBD, GCE, iSCSI, NFS, Amazon EBS. A number of these volume plugins are out there that were built out in the upstream community, brought in-house, and hardened for an enterprise-grade experience for you. So let's take a look at what we have done for storage specific to the architecture that we have here. I'm going to build a storage brick on this 4th node as well, and I'm going to show that it's also being managed by the Kubernetes master. And essentially, what we've taken is taken the local storage and turned those into bricks for a Red Hat storage cluster. And I'm going to connect these with the blue lines to indicate that they are all one cluster, and also the fact that this container has access to the cluster as a whole. Now, with this architecture, remember, it's not just about providing storage to containers, which there's probably other vendors that can do that. What we have done is hyperconverged storage. So you're actually looking at storage and applications being served out from the same host. We've actually taken the storage platform and containerized it. And obviously this translates into lower cost, but also the vision of a single control plane where applications and storage are being managed and orchestrated through a single control plane, with the eventual goal of being able to offer storage itself as a microservice in the architecture. There's a lot more coming, there's a lot more we're learning, and we'd love to hear from you. So please visit our website. It's redhat.com/storage, and join the conversation as we traverse this journey of container adoption from what we're seeing as early days today to mainstream adoption in the coming months and years. Our blog is redhatstorage.redhat.com, and we hope to continue the conversation there. Thank you.